Let us now check out our antenna system using the vswr and the return loss menus. The antenna's purpose is to radiate all the input radio frequency power as electromagnetic energy. The cable should efficiently transport the transmitter power to the antenna. If the antenna does not radiate all the power due to a frequency, impedance matching error or a fault condition, then radiation from the antenna will be reduced and power will be reflected from the fault to the transmitter, returned to sender. Our task is to locate these reflected radio frequency signals. Before any tests are made, we should have completed the frequency and calibration stages. What's the matter, Harry? Have we not calibrated it? Then we must take the time to calibrate it before we can use it. Whenever the sitemaster is first switched on, it must be left for a few minutes to warm up and stabilize. The sitemaster package contains a phase-stable extension cable and a calibrated terminator. Connect the extension cable to the RF out reflection socket. The calibration will take into account the properties of the cable so accurate measurements can be made. Now continue by telling the sitemaster what range of frequencies you will be using. Press the Mode key, then use the Up-Down key to select Frequency SWR in the screen menu. Press the Enter key to select this option. On this CD-ROM we will be using 25 MHz and 1200 MHz for all examples, even in the interactive presentations. Press the Frequency Distance key, then press the F1 soft key to select the lower frequency limit. Enter the lower frequency limit, which in our presentation is 25 MHz. You may use the up-down keys to step the frequency displayed, or you may enter the digits on the keyboard. Press Enter to save the change. Press the F2 soft key and enter the upper frequency limit. This will be 1200 MHz. Press the Enter key to save the change. At any time during the forthcoming tests, you may press the Frequency Distance key to view the F1 and F2 frequency limits, which are displayed at the bottom left quadrant of the instrument's screen. If you should change either of the frequencies or the instrument is subjected to a large temperature change, then you will have to repeat this calibration sequence again. Assuming the frequency range has been set, we can now go ahead with the calibration. If you have set the F1 and F2 frequencies, then you are already in the Frequency Distance menu. Press the Start Cal key. At the bottom of the screen you will see the text Connect Open or Insta-Cal RF out port, which is asking you to connect the calibrated open circuit to the extension cable connected to the instrument. When you have done this, press the Enter key and the instrument will sweep and measure your chosen band of frequencies. After a few moments, the sitemaster will prompt you with the message Connect Short to RF out, which is asking you to connect the calibrated short circuit to the extension cable. When you have done this, press the Enter key and the instrument will again sweep and measure. After a few moments, the sitemaster will prompt you with another message, Connect Load to RF out, which is asking you to connect the calibrated 50 ohm dummy load. When you have done this, press the Enter key and the instrument will once again sweep and measure. Now you will see the message Cal On at the top left of the screen. If the instrument was not calibrated, then you would have seen the message Cal Off, as well as a very, very large calibration off warning box in the middle of the display. Harry take note. Did the calibration go okay, Harry? Great. Connect the sitemaster phase stable extension cable to the selected jumper or feeder cable. To begin the measurement, press the Mode key. The up-down key will now scroll the display up and down the screen menu. Select Frequency SWR and press the Enter key. The instrument will now sweep between the F1 and F2 frequency limits and display in graphic form the VSWR level or the return losses. In our example, we have selected VSWR and we see that there is nothing wrong with our antenna system. An elevated reading indicates a high VSWR. The Auto Scale key will adjust the display graph vertical axis so it is best suited to the results you see on the screen. VSWR and return loss measurements are almost identical, but the presentation of VSWR is a ratio of the forward signal voltage travelling towards the antenna to the wasted signal returned, a 1:1 ratio being the perfect result. 1.1 to 1 is considered reasonable. Return loss shows, in decibels, the relative signal power level returned or reflected back from the antenna. -infinity is the perfect level, but -26 decibels is considered reasonable. To measure the return loss, press the Mode key. From the menu, select Frequency Return Loss and press the Enter key. The instrument will display the return loss graph. Your system planners or engineering department will have stated the failure level. 1.5 to 1 or -14 decibels is a typical failure boundary.